In this lecture, we are going to study about pure rolling motion of system of particle and rotation chapter. Okay. So let us take a round shape object. Let us let's say this is a round shape object, and let's say this is a surface. And let's say this round shape object is in, let's say, it combined motion, meaning that it is translating and also rotating. So let's say it is translating with some linear velocity v naught, and it is rotating with some angular velocity omega. Okay. So now what does this pure rolling means? So pure rolling mean that at the point of contact there should be no relative motion. Okay. What does it mean, like there should be no relative motion? No relative motion means that the velocity, I mean relative velocity between these 2 points, the point which is in contact, the point on a body which is in contact with this surface. So if you calculate the relative velocity between those 2 points, that should be zero. Basically the relative, there should be no relative motion. Or if there will be relative motion, so that will be not pure rolling case, that will be sliding case. Okay, here we are going to focus only on pure rolling case, like when the body is doing pure rolling. Now when the body is in combined motion, any object which is in combined motion, we know that the velocity of each and every particle or each and every point on the that body will be basically the combined, I mean it will be basically the vector sum of velocity because of translation motion and velocity because of rotational motion. Okay, so every point, like let's say we are taking a point here. Let me zoom it. So let's say we are taking a point here, another point here, another point here, this point. Let's call it A, B, C and D. So what will be the velocity of this point? Let's say the point A. So for this, it will be basically the sum of velocity because of translational. So because of translational, that there will be velocity in this direction with v naught, and because of rotation, since it is rotating in this direction, so there will be one velocity in this direction, and that will be equal to what? R omega. And this velocity is because of rotation, right? So this will be R omega, and the net velocity of this point A will be basically the vector sum of these two velocity, which will be some sort of like this. Okay, the same will go for each and every point. Like for this point it will be v naught in this direction, and this will be R omega in the same direction. For this it will be R omega in this direction, and this v naught in this direction. For the point D, which is special for us, for the point D, what it will be? There will be linear velocity v naught, and R omega will be in this direction because it is rotating like this. So R omega will be what? In this direction. So what will be the net velocity of this point D? The net velocity of point D will be v naught minus R omega, right? Because both are vertical, I mean exactly opposite to each other, they are making 180-degree angle. So the net velocity will be just this kind of, this like this. Now if we take a point, let's say this surface. Now this surface, there will be two cases. In one case, the surface can be static, or the surface can also be moving. Okay, so let's say we are taking the static case, like this surface is not moving, so the velocity of this surface is zero. Velocity of this surface is zero. So the point which is here on the surface, their velocity will also be zero. So let's say we are taking a point on the surface and we are calling it S. So the velocity of point S will be what? Zero. So now we know that for pure rolling there will be no relative motion. Okay, so basically it's mean that the velocity of these 2 points should be same. Okay, only that there will be no relative motion. So the velocity of point D is this, and velocity of point S for the surface which is stationary, not moving, is zero. So basically this should be equal to zero for pure rolling. So what we are guessing, for pure rolling, the velocity of S should be equal to velocity of D. only that there will be no relative motion. Velocity of S is 0 and velocity of D is what we have calculated, V naught minus R omega, right? So this will be V naught minus R omega. So for pure rolling, this will be like V naught, it should be equal to R omega. Okay, so this is the condition for pure rolling, and this is when the surface is stationary, surface is not moving. Okay, when, I mean, this is the condition when surface is stationary. Okay, now what will be the case when the surface is also moving? So let's say the surface is also moving in second case. So we are taking the same case, same thing, but now the surface is moving. So now the velocity of surface is non-zero, and let's say call it like Vs or Vs not, let's call it something else, like let's call it U, because V naught we have taken. So let's say the surface is moving with velocity U in this direction. Okay, so now the velocity of surface, velocity of point S is not 0, it is U. Okay, so now the condition of pure rolling will be what? The condition of pure rolling is that will be always like there will be no relative motion. This is the fundamental statement, and this statement is valid in everywhere when you are solving problems related to pure rolling. At the point of contact, there should be no relative motion between the point of contact. So now there should be no relative motion between the point of contact, meaning that velocity of D should be equal to velocity of S. So velocity of D should be equal to velocity of S. Velocity of D is what? V naught minus R omega, and that should be equal to velocity of S, which is U. Now this is the condition for pure rolling. Okay, for pure rolling, when surface is moving, when surface is moving. Okay, now let's say it has also acceleration. Here we have not talked about acceleration, like we are assuming that linear acceleration is 0. This is translating with constant velocity. Let's say for the case it is not, and then velocity is not constant, like it has some acceleration also. So in that case, what will be the condition for pure rolling? So now we are, let's take another case for accelerated motion. I mean pure rolling for accelerated motion. Okay, so we are going to same case like, and let's say now this velocity V naught is not constant, so it has some acceleration also. And let me erase these things. Let's say this will have some, sure. Sorry, I accidentally erased everything, so let me do it again. Let's say now let's say this object is moving with some acceleration. It will have some velocity which is changing, obviously, which will keep on changing. But now let's say this object has some acceleration A. Okay, so it will, this body will be rotating, and this will also have some angular acceleration, and let's say this angular acceleration be alpha. Let's call this point C. So now what will be the condition for pure rolling? So now for pure rolling, I mean there should be no relative acceleration at the point of contact. Now the condition will be like this. Okay, so how will you calculate the acceleration now? The same way we were calculating the velocity. I mean, how we calculate the acceleration of each and every point for a particle which is in combined motion. So it will be same. The acceleration of every point on this body will be because of the vector sum, or will be equal to the vector sum of acceleration because of translational motion and acceleration because of rotational motion. So let's say this point A, for example, let's say this for this point A, net acceleration will be what? This acceleration A because of translation, and since it is rotating with some angular acceleration alpha, so there will be one tangential acceleration in this direction, and that will be equal to r alpha. Okay, so it will be r alpha. So net acceleration of this point A will be what? The vector sum of these two acceleration. The same will go for B and C also. For B it will be A in this direction and r alpha also in same direction. For C it will be A in this direction and r alpha in this direction. For point D the acceleration will be like A in this direction and r alpha in this direction. Okay, so the net acceleration of point D will be what? It will be equal to A minus r alpha. Okay, and let's say this surface is stationary we are taking, or let's say this and this acceleration, its acceleration is 0. This is stationary, then anyway its acceleration will be 0. So we are not, I mean we are assuming that this surface is not accelerating, so its acceleration is 0. So for relative, I mean for pure rolling, what we know that the relative acceleration at the point of contact should be 0, or there should be no relative acceleration. So for that, acceleration of D will be equal to acceleration of S. S is a point on surface, and we know the acceleration of S is 0, so it will be A minus r alpha will be equal to 0. So this will be equals to what? A should be equal to r alpha. This is the condition for pure rolling for accelerated body, when there is no acceleration in the surface. By default we are assuming it. Okay, so this is the condition for pure rolling for accelerated motion. Okay, now there are some points which you should remember or you should take care of while solving problems related to pure rolling. Okay, so the point which is in contact here, since for pure rolling that point is not slipping, or there is no relative motion between those points, the point which are in contact, so the friction force which is acting at that point, that will be static in nature. Okay, and we know that whenever the frictional force is static in nature, so in that case the magnitude of the frictional force is unknown, we can't say anything. So it can lie anywhere between frictional force in static case, it can lie anywhere between 0 to mu into n, where mu is the coefficient of static friction. Okay, so this is the first point you should take care of. Like this frictional force, the magnitude of frictional force, you can't say directly like it is equal to mu n. Okay, so it can be anything because that frictional force is static in nature. Okay, the second point is that since the point, I mean the frictional force is static in nature, so it will not do any work. Okay, so there is no work done, so there will be no work done, so it means there is no work done by frictional force. Okay, so there will be no energy loss. Okay, so the mechanical energy we can conserve in these cases where the frictional force is static. Okay, provided the condition that there is no external forces acting on it and there is no non-conservative force, other non-conservative forces are acting. Okay, so in that case, if there is no external force, I mean the summation of external force, let's say is 0, and let's say and no other non-conservative force is acting so in this, and the frictional force is not doing any work because it is static in nature, so mechanical energy will be conserved. So mechanical energy will be conserved. Okay, so these are the few points which we should take care of. Let us solve one example, like how to solve problems related to it. Let us take one example. Okay, let's say this is a surface and this surface is stationary, let's say, and let's say this is a round shape object, and let's call it like, let's say this is a sphere. This object is what? A sphere. Let's say a force F is acting on its center of mass F. Okay, and it is given that this body is performing pure rolling, this body is in pure rolling motion. Then calculate what will be its acceleration. First, what will be the acceleration of the body, and second, let's say we have to calculate what will be the frictional force F, or let's say frictional force. What will be the frictional force? Okay, so these two things, let's say we have to calculate in this case. So for solving problems like this, what we do is that we write three kinds of equation. The first kind of equation is what? For forces. Our first step will be what? Before writing equation, what will be our step? First we will draw free body diagram, like what are all the forces which are acting on the body. So let's say this is a body, and what are all the forces which are acting? So one force is F, it is given here that it is acting. Now another force will be what? There will be some frictional force which will be acting on this body. Now what will be the direction of frictional force? Well, if you don't know anything, if you have no idea about in which direction I should take the direction of frictional force, you are free to take any direction. Okay, you can take any direction, and if that direction is correct, the frictional force is actually acting in that direction, so when you will solve the problems, you will get the value of frictional force with positive sign. Okay, and if you have taken the frictional force in wrong direction or other direction, then after solving the problems, you will get the frictional force with minus sign. It just means that the direction of frictional force is opposite to what you have taken. Okay, the magnitude will be anyway same. Okay, in both cases, either you take this way or this way. Okay, so this is the basic fundamental things which you should take care. So let us take the frictional force acting in this direction. Let's call it F. Okay, so what are all the forces which are acting? These two forces. One will be mg in this direction and another will be normal in this direction. And in vertical direction it will be what? And it is also given that the mass of this object be, let's take it capital M, and its radius is capital R. This is a sphere which mass is M and radius is capital R. This is also given, and this F is also given, let's say. Okay, so other things is what? This mg will take act in downward direction, and normal will be acting in upward direction because of this surface. So in vertical direction, now we are done with the forces. Now what we will do? We will do force balance, which we have done in which we have learned in Newton's laws of motion, like summation of all forces is equal to mass into acceleration. So if you do the apply force equation in vertical direction, it will be simply N is equal to mg. Okay, in horizontal direction, if you apply the force equation, what it will be? F minus small f, which is frictional force, capital F minus small f, will be equal to mass into acceleration. So this body is, let's say this body is moving with acceleration a in this direction. It will have some acceleration also alpha. This two are unknown things. We don't know what will be the acceleration. Anyway, we have to calculate, and this alpha we also don't know what it will be. So this is one force equation. Okay, let us call this like this is first equation, this is second equation. These are force equation. Now the next equation will be what? Torque equation. Okay, summation of all torque is equal to I alpha. Okay, so what are all the torque which is acting? So let us calculate the torque about this center of mass. So okay, so if you calculate the torque about this center of mass, the torque because of this F will be 0, the torque because of this normal will be 0, the torque because of this mg will be 0, because all forces are passing through this center of mass. The only force which will provide torque will be what? This frictional force. Okay, so let us call this small f. I mean the frictional force is a small f. So torque will be equal to what? Torque will be equal to R into a small f. So this will be capital R into a small f, that will is equal to I alpha. And I is what? Moment of inertia of the sphere about a point which is passing through its center, and its value will be equal to what? 2 by 5. For a sphere, the center of mass, I mean moment of inertia is what? 2 by 5 mr square. For solid sphere, this is solid sphere. For hollow sphere, sorry, for yes, so for solid sphere it is 2 by 5, sorry. For hollow sphere it is 2 by 3 mr square. Okay, so this is solid sphere. So torque is equal to I alpha. So this is I and this is equal to I into alpha. So this is third kind of equation. Third, not second kind of equation. First kind of equation is what? Force equation. Second kind of equation is what? Sorry, now I am visible. So first kind of equation is what? Force equation. Second kind of equation is what? Torque equation. Third kind of equation will be what? Condition for pure rolling. Okay, so what are the conditions for pure rolling? We have seen, like the surface is stationary. If nothing is mentioned, take this stationary. So this will be equal to what? A should be equal to, I mean this point of contact will be, what will be the acceleration of this point of contact? That will be A, and R alpha will be in this direction, and this should be 0. So A will be equal to R alpha. This is condition for pure rolling, just we have seen. So this A will be equal to R alpha. Let's call it this fourth equation. Okay, now what we will just solve this equation and get the desired result, whatever asked, like acceleration asked, frictional force has been asked. So whatever the quantity that will be asked, the same kind of equation we will write for each and every problems like this. Okay, so let's start solving now. So we have to calculate this acceleration acceleration small a. Okay, so what we will do, let us put the value of frictional force F value from here, from equation 3. I mean put the value of F from equation 3 to equation 2. Okay, so what you will get, so F, capital F minus small f is what? 2 by 5 mr square alpha divided by capital R. Okay, that will be equal to what? Capital M into A. So this is equal to what? Capital F minus 2 by 5 m by r will cancel, m r alpha is equal to m a. Okay, and R alpha is equal to what? A from equation 4. So we will put the value. Okay, so we'll put the value here. So this will becomes what? Capital F minus 2 by 5 m a is equal to m a. This will be equal, becomes what? Capital F is equal to, take that side, 2 by 5 plus 1, it will be 7 by 5 capital M into A. So from here this acceleration will be what? 5 capital F by 7 capital M. So this will be the acceleration which is asked. So this is the first answer. Second answer is what? Frictional force has been asked. Okay, so frictional force will be what? So for frictional force we can use this equation. Okay, so frictional force is what? Let us solve here only. like F is equal to what? 2 by 5 mr square alpha by capital R. Okay, so it will be 2 by 5 m r alpha. Okay, and r alpha we know equal to what? A, and A we just have calculated. A is what? 5f by 7m. So this will be 2 by 5 m, or this is 5f by 7m. Okay, so this will be what? Something will cancel, 5 will cancel, m will cancel, and it will be what? 2f by 7. So frictional force will be equal to what? F will be equal to what? 2 capital F by 7. Okay, so this will be the second answer. Okay, so this is the frictional force and this is the acceleration in this case, and this is pure rolling case. Okay, so this is all. This is the way we solve problems related to this. Okay, thank you.